All right, so we're given a graph of f here. F is a function of t, and g is defined to be the integral from 0 to x of this function f. So what is g of 2? Well, g of 2, this is really g of x, so x is 2. So it's the integral from 0 to 2 of f of t. And what is the integral from 0 to 2? Well, it's the area. We know it's going to be negative because the graph is under the x-axis. So the integral is going to be this area here. Well, as a negative number because the function is negative, yeah? So what is the area? It's a triangle. 1/2 of base times height. 2 times 1 is 2, and half of 2 is 1. So the answer is -1. What is g of 4? Well, g of 4 is the integral from 0 to 4 of our function f. So now we're going from here to here. This area is going to be positive, this area is negative, and so we're going to get the integral from 2 to 4. This part is going to be the area of that triangle, half of base times height. Half of 2 is 1. So this is -1 plus 1, which is 0. -1 plus 1, which is 0. So that's part A. Part B, on what interval, or intervals, might be more than one, is this function g, on what interval is it getting bigger, increasing? Well, this is going to increase when our function f is above the x-axis, because that's when we're adding up positive numbers, right? Because as we talked about before, the integral, let me just refresh our memory. If this is our function here, some function f, the integral of f, let's say this is 0, let's say this is 3, and let's say this particular example, let's say f is a function of x. So what is the integral of f with respect to x? Well, remember, this is an integral by definition is a Riemann sum, and all we're adding up is your dx is basically a little sliver of, that's our base, f is our height, right? So we're adding up a bunch of area of the rectangles, but when we're under the x-axis, f is negative. So we get a negative times a positive, which is a negative. And by definition, remember, the integral is the limit as the number of those rectangles goes to infinity. So the error is going to go to 0. We're going to get the exact area. But in this case, it's going to be negative, right? That's the reason why. So here our function is going to be negative. We did this in part A, that's -1. Once f goes above the x-axis, we start adding positive numbers to it. Positive, positive, it's going to keep getting more positive. And right here, we're going to jump from adding positive numbers to this to, once we cross over 7, we're going to start adding negative numbers, which means the overall value of this is going to get smaller. So between 0 and what number does g take on its biggest value? It's right here. G of 7 is going to take on its biggest value. Whoops, I answered part C first. So for what x value does g obtain its biggest value? I answered that one first, that's 7. Now let me go back to B. On what interval is g increasing? Well, very similar, it's increasing from 2 to 7. So g is increasing on the interval 2 to 7, yeah? And again, that's because from 2 to 7, we're adding positive numbers, yeah? So that's why it's increasing. Where is it decreasing? It's decreasing when we're adding negative numbers. So it's decreasing from 0 to 2. So the overall value of this summation is decreasing from 0 to 2. And it starts decreasing again, the overall value, from 7 to 9, because that's where we start adding negative numbers again to the overall value of this. So those are the answers to this particular problem, where g is defined to be the integral from 0 to x of f, and where f is a function of t.